let's just try and solve another example of the superposition principle. And there's this example now. And something to clearly observe here is that there's a dependent source here. Now, in the superposition principle's definition, you need to find the responses due to the independent sources. So you won't actually remove this source ever because this is a dependent source. So I'll just show how it is done. And another thing to remember is that the value it is dependent on, it will be different for each time, for each source you are considering. So let's just start off by considering this voltage source and remove this one. So whenever you remove a current source, you get an open circuit. So I'll just redraw my circuit now. And there's this 2 ohms resistor, and because this is an open circuit, I won't draw anything here. So this is the 1 ohms current resistor, and then there is the 2ix. I'll just mark it. I'll just put a comma here so to signify that it is for this source, the first one. And this is not ix now, this is ix dash. So by the way, the question is to find ix. So now I'll just solve this circuit. So I'll apply the KVL starting from here and move clockwise. So 2ix dash plus 1ix dash plus 2ix dash is equal to 0. So ix dash would come out to be 2 amps. So ix dash is basically 2 amps for the voltage source. So now I'll do the same for the current source, and I'll redraw the circuit, removing the voltage source. By the way, I'll just remind you again that when I say I'm removing a source, that means I'm putting its value to be 0. So when I remove a voltage source and I put the voltage to be 0, the voltage of a short circuit is always 0. And when I put the current to be 0, the current of an open circuit is always 0, because in an open circuit there is no path for the current to go, so there is just a 0 amps current. So I'll just redraw the circuit for the current source now. Alright, so this is my circuit for the current source. I have just put the voltage source to be 0, so there's a short circuit here. So I'll now find ix double dash, and notice here how I've changed the value of the dependent source to be 2ix double dash 2, because this is the current source I am considering. So after solving this circuit through some rule like mesh analysis or the nodal analysis, I find ix double dash to be minus 0.6 amps. So now to find ix, I'll just find the algebraic sum of ix dash plus ix double dash, which comes out to be 1.4 amps. So to actually test if this rule is actually working, you can also solve this entire circuit directly and find ix, and I'm pretty sure the value would be the same. So this is how superposition works, and I hope this example makes it more clear. The main key takeaway is that whenever there are dependent sources involved, you would always change their dependency or the value they're dependent on according to the source you are considering. So this is something you need to remember. So for every independent source, there's an entirely new circuit. So I hope this makes things more clear now.